Hello! Welcome to a brand new unit. I want you to go to Go Formative right now if you were able to take the test and check out any comments or scores. Look at Synergy. I have put your grade in there. But that was for last unit. This unit, we're going to be focusing on law of sines as well as law of cosines. This week is just strictly about law of sines. So we'll be learning about that today as well as Wednesday or Thursday, depending on what class you're in. Also, you're going to get your special word of the lesson at the very beginning. Your word is alpaca. So if you end up going to any of the Zoom classes, please give me the word alpaca. All right, so law of sines deals with triangles. We're dealing with triangles this unit. There will be no graphing at all. Also, please make sure that your calculator is in degrees instead of radians. No pies at all during this time. I'm sure many of you are very happy about that. We're going to be dealing with triangles. Now, if you remember your triangle congruency statements like SAS or SSS, we are given 3 pieces of information about a triangle to say, hey, this is congruent. It's very similar here. However, it's just situations about when can we use the law of sines. Our first situation when we can use the law of sines is when we're given an angle, and a side. So you're like given this angle here, and then this side left on the outside. So that's angle, side. Another situation that we might see is angle, side angle. Now, some of you may be like, Ms. Wayne, that is the same thing. It's the same amount of information, but where that side is placed is very important. So you'll notice the side is actually oh, I forgot it was a lightsaber. Ha ha. Sorry. I forgot the side. Pardon me. The side is placed in between the 2 angles. So if I have my angle here and my angle here, I need to be focusing on that side there in the middle. So making sure you have proper placement there is going to be very, very important. The last situation that we're going to start talking about today and finish up next lesson is side, angle. Yes, I'm doing it this way specifically so it does not spell the word ass. Anyway, side, angle, when you're given one angle and then 2 separate sides, notice that the angle is not in between the 2 sides that you're given. That's side, angle, side, and that is something different, and we're going to deal with that next week. So these are the situations when we can actually use law of sines. Now, in order to use law of sines, you have to know what law of sines is. So first, we're going to set up a triangle. Let's do that in blue. So we're going to set up a triangle right here. Now, you have to make sure that your triangles are properly labeled. Now, what I mean by that is if I have an angle A over here in my bottom left-hand corner, the opposite side also has to be side A. You'll notice that all of my angles are going to be uppercase. All of my sides are going to be lowercase. That is something that has universally done. So please make sure you do that. That's not just like a handwriting thing. Like, please have all your angles be uppercase, all your sides be lowercase. So for instance, in the bottom right-hand corner, that's going to be a capital B for angle B. And all the way across from that, you're going to have side length B, baby B. Your angle C will be the last one here. Your side length C will be here. I want you to notice that if we take a look here at angle B is pretty small. It's the smallest on the triangle. You'll also notice that side length B is the smallest. Your smallest side has to be across from your smallest angle, and your largest side has to be across from your largest angle. So when we look at, law of sines, we have to use sine somehow from our sine, cosine, tangent. But in order to do that, you need a right triangle. So I'm just going to draw in the height of this triangle right now and create 2 right triangles. So I'm actually going to create 2 ratios right here for us right now. We'll do sine of A. So if we do sine of our angle A, we're going to need our opposite over our hypotenuse. Now in this case, when we're looking specifically at this triangle here, our opposite, wrong color pen, there we go. Our opposite is going to be our height, so not hypotenuse, just height. And then our hypotenuse will be b. And if I solve for h, if I multiply by b on both sides, I get b, my side length b times sine of my angle a is equal to h. So what if I did that for the other right triangle I've drawn right here? So let's see, this will be sine of angle b is equal to opposite side, which is h, over the hypotenuse, which is side length a. So from here, if I was to solve to get h by itself, I can multiply both sides by a, get a times sine of b is equal to h. And I can say, hey, since both of these are equal to h, I'm just going to set them equal to each other. So we're going to say that b sine of a is equal to a sine of b. Now I look at that and I go, that's kind of messy. What if all of the same letters were on the same side? I feel like that would make life so much easier, and I agree. So that's exactly what we're going to do. First thing we're going to do is we're going to divide both sides by side length b and end up with sine of a is equal to side length a times sine of b over side length b. And I'm just going to go through, divide everything by the side length of a. Oops. And you should get sine of a over a, side length a, is equal to sine of b over side length b. And this right here, that is our law of sines. If you were to do this again, reorient your triangle and involve your side c and angle c, the same would apply. So sine of angle c over side length c is also equal to all of this. Or if you don't like to have your angles on top, you'll see me do that just because that's how I specifically learned it. As long as your angles are lined up with your with other angles and your sides are lined up with other sides, it doesn't matter. So if you have your side length a over sine of angle a is equal to side length b over sine of angle b, which is equal to side length c or sine of angle c, that is also okay. So this information right here, this is what we're going to be using. This is our law of sines. I'll write that in red. That is our law of sines. We get that using our right triangles in something that is not a right triangle, because we come across triangles that are not right all the time. So what I'm going to do with you right now is I'm just going to go through 3 examples with you. I have a feeling this is going to be a short video. And then if you need more practice or, just to keep up with your skills, there's going to be a homework and go formative. So let's move on here. Our very first problem, first example, I'm going to do an angle, side example with you. So I'm going to do an angle, side. I'm just looking at my triangle to make sure that I'm giving you all the right information. Ooh, that is a wobbly triangle. All right, so I'm going to label everything A, B, and C. Again, notice my same angles across from the same side. You also notice I just drew this triangle. It may not be to scale. That is okay. I am okay with that. That will just happen. So here's the information I'm going to give you. We're going to say that, let's see, what do we want to say? We want to say that angle B is 30 degrees. We're going to say that angle C is 95 degrees. And we're going to say that B is a length of 10, I don't have any units for this problem, so you can say 10 centimeters, inches, whatever you want. So this is an example of angle, side. So now we have to go through and find the rest of the information. So we need to find side length C, we need to find angle A, and we need to find side length A. Now, we have enough information to find angle C if we, or pardon me, side length C if we want to. However, I notice we already have two angles, and I know that, where are we here? I know that a triangle is 180 degrees. So if I do say, hey, my angle A is going to be 180 minus the 95 degrees minus 30 degrees, that's going to give us 55 degrees. So I can already go in and say, okay, that's going to be 55 degrees. Cool. Done with one out of my three parts. So for the next one, we need to find side length A or side length C. It honestly does not matter which one we need. All I know is that I need to set it up equal to my B's. So we'll do sine of 30 degrees over 10. Now the reason that we need to do this is because we can only have one missing piece, and it's either going to be our side length A or side length C. So I need to find a pair of information, a side and an angle, that I already know. So let's just set it equal to my A's just for fun. So we'll say that this is equal to sine of 55 over my side length of A. So now I need to go through, solve, do what I can. From here, I'm going to cross multiply, or use my butterfly method, if you will. I can do this because both these fractions are equal to each other. And that's going to give me my side length of A times sine of 30 is equal to 10 times sine of 55. And then from there, since I have A times sine of 30 is just a number. So I'm going to divide both sides by sine of 30. Please do not plug sine of 30 into your calculator yet. If you go through and you plug things in early and you start rounding, your final answer is going to be totally off. So do not plug anything into your calculator until the very end, which is when you have your variable by itself. So A is equal to 10 times sine of 55, whole thing divided by sine of 30. This is something you can plug into the calculator. And when you do, for side length, please round to the second decimal place. For angles, we're going to round to the first decimal place, and we'll do that a little bit later. But for our side length here, it's going to be 16.38. So side length A is going to be, where is it? I'm going back to my triangle, 16.38. Now, something to be very cautious of, a lot of people right now will try 16.38 squared plus 10 squared is equal to c squared. That only works for a right triangle. We are not able to do that here. So the reason we are using law of sines is because we are not dealing with a right triangle. So please, please, please do not do that. What we can do, however, is go through and do this work again, but now find side length C. So like I said, it didn't matter which side you started with, you're going to get the same thing either way. So let's set sine of 30 over 10. And I can use my pair of A's if I want to. However, that has decimals, and I don't want to deal with that right now. So we'll do sine of 30 over 10 is equal to sine of 95 over our side length C. So we're going to copy these steps again. Cross multiply and get C times sine of 30 is equal to 10 times sine of 95. Then I'm going to divide both sides by sine of 30. And I end up with C is equal to 10 times sine of 95 over sine of 30. If you're wondering how much work you need to show, all the steps I've done in red, you do not need to show me. However, all the steps done in green, I do want to see that. So please make sure that when you're doing your work on homework or something, show me at least the steps in green. You can also show me the steps in red if that helps. Let's see, after we plug this into our calculator, we should get 19.92. And again, I'm going to go back to my triangle, make sure everything is labeled 19.92. So this is what a full problem looks like. I need to find the rest of the information in my triangle, and that's what I have. So that was our first example with the law of sines. Now, for anything with two angles, so angle, angle side like this, or angle side angle, no matter what is only ever going to have one solution. The side-side angle, however, gets very tricky and into the ambiguous case. We're going to start the ambiguous case today, and we're going to finish that next class period because it's a real big thing. So let's get into the ambiguous case for law of sines. I'm going to move this up. Ambiguous case for law of sines, side angle. Now there actually happens to be 5 different scenarios that can happen. We're going to go over 2 of them today because 2 of them deal with when the angle that you're given, I'm going to highlight that. When the angle that you're given, if that angle is greater than 90 degrees, what are the different situations that we can have here? So there's only going to be 2 situations for this situation. I need a better word than situation. I'll think of something. Or if you want to message me and tell me a synonym for situation, I would appreciate that. So I'm going to give you first example. First example. We'll pretend that's not curved. Okay, so here's my triangle. Let's see. I'm going to give you this angle here is 100 degrees. We're going to say that the side length across from it is 7. The side length next to it is 15. Okay, so this is an example of angle, side, side angle. Now I look at this and I go, okay, Miss Twain told me earlier that the largest angle needs to be across from the largest side. I think I'm just going to move to an arrow. So largest angle across from largest side. So, well, 15 is bigger than 7. So this angle across from 15 has to be bigger than the other angle. So this has to be at the very least like 101 degrees. But that doesn't make sense because 100 plus 101 doesn't even make a triangle. So this can't work because the largest side, like 100 has to be the largest angle because if these are 101, that doesn't make a triangle. So if this doesn't work, then this is just an example of a no solution. If the angle is greater than 90 degrees and the largest side is not across from the largest angle, okay, boom, no solution, done. If you did not notice this and you tried to solve it, you're going to get a domain error because this triangle does not exist. So if you get a domain error, you're not doing something wrong. This is just an example of a no solution. So just a reminder, the largest side must be across from the largest angle. So what if we switch these sides? So I'm going to draw this triangle again. To the best of my straight lines today are really not straight. Okay, so there's my triangle. We're going to make this the same one. It's 100 degrees. We just said we were going to switch those. So this will be 15 and this will be 7. So okay, my one angle is larger than 90 degrees. My largest side is now across from my largest angle. Okay, this works. This makes a triangle. This is going to be an example of a one solution. So again, if your angle is larger than 90 degrees, just always double check that the largest side across from the largest angle. If it is, it works. Cool. That's going to make a triangle. If not, that's an example of a no solution. So let's go through, solve, do what we can. Now, First, I'm going to go through label stuff. So let's see, we'll put angle A over here, which means 15, that's side length A. Put B over here, C, which means that this 7 is actually side length B. Side length C is over here. Okay, so we need to find our C's, and we need to find our B. Now I take a look at this. I have my angle A's. So let's see, we'll have sine of 100 over 15 is equal to sine of, I don't know what my angle B is, but it's just going to be sine of B over 7, because I do know that side length. So the missing piece here is my angle B. I cannot use my C's right now because I do not know the angle or the side for that. So when I do my work here, again, just like what we did before, I'm going to cross multiply. We're going to have, I'm also going to move this up. Boop-doo. Yeah, okay. We're going to have 15 times sine of B is equal to 7 times sine of 100. Then I'm going to divide both sides by 15. And I get sine of B is equal to 7 times sine of 100 over 15. Now here I look at this and go, okay, I need to get B by itself. So in order to do that, I have to undo sine or find the inverse. So my last step here is to have B is equal to sine inverse of 7 times sine of 100 over 15. So it's sine inverse of all of this stuff. Now I can plug it into my calculator. Please don't do that early. But when I do this, and again, please angles to the first decimal place. When I do this, I get 27.4 degrees. Okay, so I get 27.4 degrees for this one. I'm going to go and plug that back into my, there we go, my triangle. So it's 27.4 degrees, and I go, hey, you know what? I know two of my angles now. So if I do, for my angle C, 180 minus 100 minus 27.4, I get 52.6 degrees. So let's plug that into our triangle. Okay, so I have all of my angles now. I just need to find my last side length. So let's set this up one last time. So sine of 100 over 15, so using my B's again, is equal to sine 52.6 over C. From here we will cross multiply and get C times sine of 100 is equal to 15 times sine of 52.6. And yes, I know my S's and my 5's look very similar. I'm so sorry. Let's divide both sides. Oop, oop, that's a 1. Sine of 100. And we end up with, I'll go back to that triangle in just a moment. C is equal to 15 times sine of 52.6 over sine of 100. And you get the answer of C is equal to 12.1. Now again, normally for a side length, you'd round to the second decimal place, but this is literally 12.1000004. So we're just going to say it's 12.1. So now I'm going to go back, write this up in my triangle. There we go. I know I made that kind of small. I'm sorry. Oops. Oh, whoa, that happened. Okay. 12.1. So this is just a few different examples for how to deal with law of sines. Next class period, we're going to get into the other situation scenarios. That's another one. A scenario for the ambiguous case. There are 3 more scenarios for that, and we'll spend time doing that. Please go check out Go Formative, do the homework problems, and I look forward to seeing you in Zoom.